We're back again, and we're going to start off with question number 3.
So in your book, question 3 says, in an RC series circuit has the power factor of 76%. How many degrees are the voltage and current out of phase with each other?
All right, in this case, it's a fairly simple question. Power factor is given in percent, which is not unusual. However, you need to recognize that the power factor is usually a fraction. So to get the value that you would usually get, it's going to be, you divide that by 100 and you get 2 decimal places moved over. It'd be 0.76. All right, so we need to find the angle, which they typically call theta, between the current and the voltage. All right, and the other formula for power factor is the fact that power factor is always equal to the cosine of theta, where theta is the angle between the voltage and the current. All right, so with that in mind, and what you're going to see here is 3 dots in a little triangle form. Those 3 dots basically are scientific notation that says, therefore, all right, so power factor equals cosine of theta. Therefore, theta, excuse me, theta equals cosine to the -1 of the power factor. All right, so with that in mind, and again, keeping that's equal to cosine to the -1 of 76% divided by 100, which is cosine to the -1 of 0.76. And if you put that number in, 0.76, do cosine to the -1, you come out with the angle being 40.5 degrees. All right, pretty straightforward. Again, just keep in mind, you have to know how to manipulate equations. All right.
Moving on to number 4 in your book, it says an RC series circuit has a total impedance of 84 ohms. The resistor has a value of 32 ohms. What is the capacitive reactance of the capacitor? And it gives us XC equals the square root of Z squared minus R squared.
Now, because this is a series circuit, when you get into parallel circuits, if you haven't already looked at that chapter, you're going to find out that calculating Z, okay, is very complicated, and therefore calculating X sub C is just as complicated. But because this is a series circuit, the relationship is much simpler. For example, the relationship that we're talking about here is Pythagorean Theorem, all right? And we're comparing ohms to ohms to ohms. And again, series circuit, they all add, but they add, in this case, vectorially. And considering the fact that they're a right triangle where this is Z, this is R, and this is X sub C in this case, okay? It's just a matter of using Pythagorean Theorem, all right? So that case, X sub C is equal to the square root. Notice I'm using a different symbol here for square root because just wanted to get you used to both. All right, Z is equal to the square root, X sub C is equal to the square root of Z squared minus, keeping in mind that this Z is always the big number.
The hypotenuse.
Okay, the hypotenuse. And the resistance, so minus the resistance squared, all right? We plug those numbers in that are given to us, and we get that, again, X sub C is equal to 84 squared plus 32 squared, or I'm sorry, minus 32 squared. All right, and when we put them in there, let me just make sure I didn't screw that up. All right, so, and did I Yes, I did.
Well,
I'm
let's
sorry.
just work it out real quick with the calculator then.
We'll do that right now.
We got this.
And
So 84 times 84 is how much?
so let me clear my calculator. And I've got
You guys can
84
do this along with us.
squared,
So 84 times 84 is?
7056.
And 32 times 32.
32 squared is 1024. The combination is 6032. And when we take the square root of that, it comes out to be 77.7 ohms. Okay, which is, there you go. All right, so sorry about that. Even the teacher can make a mistake.
But at least he had someone to correct them.
All right. Hopefully you got no problems with that. It's pretty straightforward. But let me get this number out of there so that you're not too fooled by it. And what was that number again, Marissa?
6032.
So it's 6032.
And then
Okay.
our answer wound up being 77.7 ohms.
All right.
So that's the right answer.
So with that in mind,
How
we'll
do we
move
write
on to the next question, which is number
So
5.
number 5 in your book that says a capacitor has a capacitive reactance of 50 ohms when connected to a 60 hertz line. What will be the capacitive reactance if the capacitor is connected to a 1000 hertz line?
In this case, it's really a simple problem if you can analyze it, all right? Capacitance is always equal to 1 divided by 2 pi frequency times capacitance, all right? Now, so this is the total reactance, all right? And in the next case, it's going to be equal to the same value, all right? Now, the thing you have to recognize here is the fact that 2 is not changing from one equation to the other. Pi is the same. The capacitance is the same because you've got the same capacitor in the circuit. So the only thing that's changing is the frequency. Now, when you look at this, you have to ask yourself, what happens if my frequency goes up? Well, if this is a larger number, then this will be a smaller number, all right?
Because we're
Which
dealing with
says
fractions.
that the two values are inversely proportional to each other. So you can look down here, and the bottom line is I created a little equation here, and I divided the two equations between themselves. And when you end up putting together like that, you'll notice that the 2's cancel out, the pi's cancel out, because they're the same. And we're left with the ratio of the reactances is going to be inversely proportional to the frequencies. And if we take and manipulate this a little further, we get the fact that x sub c for the second condition is going to be equal to the reactance for the first condition, and again, inversely. So notice over here, it was 2 over 1. Over here, it's 1 over 2. All right? So if you look at that and plug the numbers in, we have 50, which is your original reactance, and then we have the ratio of the two frequencies. And we start canceling out zeros, all right? So I've got a 0 up top, I cancel that out, cancel 1 down here, and I'm left with 5 times 6 on the top, or 30, divided by, on the bottom, 10, or 3 ohms. So you can see how drastically that frequency changed things, okay? Because as it's speeding up, to like 1,000 hertz, that's pretty damn fast. As it speeds up to 1,000 hertz, basically what happens is the capacitor can't catch up with the movement that's going on. So the actual capacitance starts dropping off. All right, so with that in mind, we have 3 more questions to go, and we'll get back to you as soon as we get them ready for you. Thanks.